Anyone seeking a license to practice medicine in China must pass a grueling trial, a 10-hour, 600-question marathon known as the National Medical Licensing Examination. Entering this arena are the defending heavyweights of artificial intelligence, OpenAI's globally dominant models, including GPT-4o, o1 Pro, and o3 Mini. Facing them is the challenger, DeepSeek R1. This is an open-weights Chinese model built under severe U.S. compute export constraints. To survive those limits, it operates on a highly efficient mixture of experts architecture. Historically, OpenAI has owned this field. On the U.S. medical licensing exam, they easily clear 90% accuracy. Based on raw compute and past performance, the expectation was simple. OpenAI's multi-billion-dollar models should dominate this test, just as they did in the West. This chart maps out the results, and you can see DeepSeek R1 demolished the curve with a 96% accuracy rate. Right next to it, the OpenAI models plateaued, flatlining at roughly 75%. DeepSeek operates on over 40% Chinese data. The language barrier isn't just about vocabulary, it's about the native comprehension of high-stakes medical syntax that generalized models haven't mastered. The second variable is textbook alignment. We can see this by looking at DeepSeek R1's internal chain of thought reasoning process. When solving case studies, the model actively references guidelines specifically from the People's Medical Publishing House. That specific publisher is the official grading standard for this exam. DeepSeek studied the exact curriculum required, while OpenAI relied on Western medical literature. Then there are epidemiological realities. Disease prevalence is not universal across the globe. This data map compares tuberculosis rates, and the difference is massive. TB incidence in China is roughly 13 times higher than in the United States. Because of that reality, over 8% of the exam focused on TB. This gave a massive advantage to the model trained on localized healthcare statistics. But the model wasn't perfect. DeepSeek RI9 actually outright refused to answer 3 obstetrics and gynecology questions. These refusals were triggered by the model's own safety and ethical filters regarding reproductive health, highlighting the tension between AI safety and clinical utility. DeepSeek's victory was engineered by perfect alignment with local grading standards, regional disease profiles, and culturally specific data. If we re-examine the English translation experiment, a critical gap remains. Looking at this side-by-side comparison, even with the language barrier removed, translated GPT-4o at 83.5. In highly specialized, culturally specific domains, raw computational scale cannot override local fluency. We are now beginning to see exactly how AI will integrate into high-stakes industries like global medicine and law. Competition used to depend on who owned the largest supercomputers. Now the advantage is shifting toward highly localized, efficient models. Future AI supremacy will be claimed by systems built to understand local textbooks, local languages, and local patients. DeepSeek's upset proves a simple truth. Context is now as critical as compute.